All right, so some of these problems, they're going to look familiar from the lecture notes, and then some of them not so much. So the very first problem, now here again, the order on your test is going to be slightly different than this. All right. Okay, but the question should be the same or similar. All right, so the first one says, which of the following cannot be a probability? So keep in mind, we talked about probability, and a probability is in between 0 and 1, right? If you're talking about decimals, but in percents, it's between 0 and 100%, right? So here we just asked to find the values that could not be a probability, right? So we want to find values that are either greater than 1 or that they're negative. Okay? So if we take a look at the very first answer choice, square root of 7, so I'm just going to decimalize all of these things. So if we were to evaluate the square root of 7, let me just reset this calculator. All right, so the square root of 7, square root of 7, okay, that's 2.64, right, which exceeds 1. So that one could not be a probability value. 20 over 7, I believe that's going to exceed 1, right? 2.8. So that is not a probability value. For C, 0.4, that's within our limit. So that could very well be a probability, right? So we're only going to pick out the ones that could not be a probability. 7.2, right? That's greater than 1. So that is not a probability. And then the square root of 1/6. Right. So 1 divided by 6, I believe that's going to fall in our range, 0.4. So we would not include E as an answer choice. All right. Problem number 2 should look somewhat familiar, right? If a ball is drawn randomly, so we're just drawing one ball out of a jar that contains 5 red balls, 11 white balls, and 16 yellow balls. Find the probability of each one of the events. Right? So A says find the probability that a red ball is drawn. So for these setups, we're going to use that classical approach of probability, which is similar to a fraction concept where you have the part that you're interested in over the whole, or in this case, the total amount of balls that are in the jar. So first, let's just find the total amount of balls in the jar. So we're going to add 5 plus 11 plus 16. And that's going to give us 32, right? All right, so that's going to be the denominator for each one of these particular probabilities. So a red ball is drawn. So again, we're going to put the total of all of the balls in the jar. All right, that's our denominator, 16. And out of those 16, how many are red? 5, right? So that's our probability, 5 out of 16. Now we can decimalize these things, but in the calculator, if you're leaving it as a fraction, just make sure it's always reduced to the lowest terms, right? So 5 out of 16 is 0.313. Let's see, 5 plus 11 plus 16. The 32 comes in if you add up all of the balls in the jar. All right. So that's where this 32 comes in, right? 5 red, 11 white, and 16 yellow balls. That gives us a total of That's 5 out of 32. Okay. All right. So 32 is our denominator. All right. So if we decimalize that 5 divided by 32, we get 0.156. All right. So for number 2, a white ball is drawn. So again, the total amount of balls in the jar is 32. And out of those 32 white balls, how many are, out of the 32 balls in the jar, how many are white? 11. All right, so that's our probability. 11 out of 32. A yellow ball is drawn. So that's going to give us 16 out of 32. And that's going to reduce down to 1/2. All right, so in the calculator, just as a reminder, 16 divided by 32, it decimalizes it as 0.5. However, you can change that decimal to a fraction. All right, and it's going to always give you that fraction in lowest terms. Okay, what's the probability a green ball is drawn? 0, right? Our denominator will be 32, right? There's 0 green balls, so 0 divided by 32 will give you 0. And what about E, a red or a white ball? Right, so here again, the denominator is 32. So how many red balls are there to choose from? 5 plus how many white balls? 11. Right. So 5 plus 11 is, I'm getting ahead of myself. There are 5 red balls. Okay, and 11 white balls. 5 plus 11 is 16, and 16 over 32 is 1/2. So any questions about number 2? That should look somewhat familiar. Now, problem number 3, I believe that was in module 1 of the module 1, part 1 on the handout, and I just skipped over this altogether, so we will go through this now. All right, so it says answer the following questions based on the spinner below. You may assume that each region of the spinner is equally likely. Okay, so they're equally likely, or each interval is equally spaced, right? To make all of these things have like the same probability. So if we take a look at the spinner, how many numbers on the spinner are there to choose from? 12, right? So our total is going to be 12. All right, so if we liken this to the fraction or the classical approach to probability, right? 12 is going to be our denominator. So what's the probability that the spinner lands on 3? Right, where there's 12 possible numbers the spinner can land on, and out of those 12 possible numbers, how many are 3? Just 1, right? So that probability is 1 over 12. Find the probability that the spinner lands on an 8 or a 6. Well, here again, our denominator is what? 12. So how many 8s are there? Just 1 8. How many 6s are there? Just 1 6. So there's a possibility of landing on 2 places on that spinner, right? Either an 8 or a 6. So we're going to reduce 2 over 12 down, and that should give us 1 6, right? So notice a couple of these things use or. So we talked about the addition rule, where it's like probability of A plus the probability of B minus the A and B. Those don't apply here, right? Because we have just 1 8 and 1 6. We don't have a 6 and an 8 that are both in one particular part of the spinner, right? C says the spinner lands on an even number. All right, well, here again, there are 12 places on the spinner. How many of those numbers are even? 6, right? So 6 over 12 gives us a probability of 1/2. D says the spinner lands on a multiple of 7. All right, so here again, there are... I just thought I wasn't recording. Okay, again, there are 12 possible spots on the spinner. And out of those 12 possible spots, how many are multiples of 7? Just one, right? Which is just 7. So remember, multiples are 7, 14, 21, right? You take the 7 times 1, 7 times 2, 7 times 3, all right? And so on. So there's only one multiple of 7, which is 7. So that probability is a 12. E says the spinner lands on a number greater than 7. So there's 12 possibilities. Okay, now this says greater than 7, not greater than or equal to 7. So since this says greater than 7, you would not include 7, right? But you would include 8, 9, 10, 11, and 12, right? So there's 5 numbers greater than 7, so we get 5 12s. Now, if that were to say, greater than or equal to 12, then greater than or equal to 7, then you would include 7. F says the spinner lands on a number less than 11. Less than or equal to 11. So here again, the denominator is 12. So would you include 11? You would include 11. So that would be how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that probability is 11 over 12. All right, so just be mindful of the word equal to. Right, if it's equal to, you're going to actually include that value. If you don't see the word equal to, you don't include it. All right, so I believe that was in module 1, part 1 on a lecture note somewhere. All right, this one should also look a little bit familiar. It says a study reports that 38% of all people own dogs. Suppose that 2 people are chosen at random from the population. All right, so remember, a population is a large group of individuals. Are the individuals dependent or independent? Well, since we're dealing with a large population of people, then we're looking at independent samples, right? Because you choosing one person and their response doesn't have anything to do with another person that's chosen in their response. Okay, so they're 2 independent events. The reason why, because they derive from a large population. And C actually wants us to determine that probability. So since we're choosing 2 people, okay, well, I'm going to map this out using that fundamental counting principle. So for the first, and these blanks in this instance represent people chosen. So this would be the first sample person, and the second blank would represent the second sample person. All right, so now let's determine the probability. So what's the probability that the first sample person will own a dog? Well, they sort of give us that probability in the question, right? It says a study reports that 38% of all people own dogs. So the probability that the first random chosen person would own a dog would be 38%, right? So when you use the percentages and calculations, you got to revert them back to decimals. So 38% is 0.38 as a decimal. The probability of the second person has a dog would also be what? That same 38%, right? So this would be 0.38 squared, which is 0.38 squared is rounded to 3 decimal places, 0.144. Right, that's about a 14% probability that 2 sample people own dogs. Right.
So with 4B, is it A because it has population in the question? So like independent, when you talk about the marble in the jar,
Right.
It's A because of the population in the question.
That's right. This one would be A because of the population in the question. As far as the jar thing is concerned, when it would still be independent because you're reaching in and shaking it up and pulling just one marble out. Okay.
And then it would, if it was the marble sense, it would be B because it's without replacement.
That's right. That's right. That's right. That's right. That's correct. All right. Okay, 5 should look somewhat familiar. This was, I believe, in the first part, module 1, part 1. So it says, suppose a jar contains 6 red marbles, 30 and 32 blue marbles. If you reach in the jar and pull out 2 marbles at random at the same time, answer the following questions. Are the events dependent or independent? This is going to be dependent because you're reaching in and you're pulling out 2 marbles. So the first marble that your hand physically touches affects the probability of like the second marble. Okay. And the reason why is because the marbles are chosen at the same time. Right? So if you were to like choose one marble, put it back, and then pick another one, those would be independent events. Oh, I'm sorry. All right, and now we're asked to find the probability that the 2 marbles we choose are red marbles. All right, so I'm going to map out 2 outcomes. All right, so this is the first marble chosen, and this is the second marble chosen. Right, but they're at the same time, so. All right, so let's determine the probability. So what's the probability that the first marble you choose is a red marble? Right, well, we're going to use that the classical approach to probability. We're going to set it up in a fractional type aspect. So how many marbles are in the jar altogether? It should be 38, right? So the total is 6 plus 32, which is 38. So there's 38 marbles to choose from. Out of those 38 marbles, how many are red? 6, right? So now we're not putting that marble back in. We're actually pulling out 2 at a time. So since we've already taken 1 marble away from the total of 38 marbles, for that second choice of marbles, how many marbles are left? 37, right? Out of those 37 marbles, how many are red? 5, right? Because we've taken 1 away. All right, so when you multiply fractions, you multiply the numerators and multiply the denominators. So we have 6 times 5 divided by 38 times 37. 6 times 5 is 30. 38 times 37 is 1406. And 30 divided by 1406 is, rounded to 3 decimal places, 0.021. I know I just did a lot of steps with this calculator, right? Multiply the top, multiply the bottom. You could actually put all of this in one step, but you got to be careful. You must put a set of parentheses around the numerator and the denominator. So just to show the difference, I'm going to put the top in a set of parentheses, and we have 6 times 5. I'm going to close that off. I'm going to divide. I'm going to open up another set of parentheses. And I can do that all in one step, right? However, if you just put in 6 times 5 divided by 38 times 37 without a set of parentheses, you're going to get something that's way off. All right. So if you're doing it all in one step, I would use a set of parentheses to force the calculator to perform the order operations. All right. All right, any questions about number 5? Okay. I believe all of these should look somewhat familiar so far. All right, 6 says a die is rolled. So whenever you see die, that's a 6-sided dice, unless it says otherwise. And there is another question on here where you're using something other than a 6-sided dice. So we're rolling the dice twice. What is the probability of a 5 on the first roll and an even number on the second roll? All right, so we're going to map out 2 outcomes. So keep in mind these are independent, because when you roll the dice the first time, you pick it up and shake it or blow it or whatever, you roll it again, those rolls don't have anything to do with each other. So they're independent events. So what's the probability of rolling a 5 on the first roll? Well, since it's a 6-sided dice, the denominator is 6. And on that 6-sided dice, how many 5s? It's just 1 5. So 1/6 is a probability of rolling a 5. On the second roll, what's the probability of an even number? Right, 3. The total is 6. So I'm going to multiply my numerators, multiply my denominators, and if we reduce, we get 112. Now be careful on number 7, because it wants you to answer it as a percent. It says you don't need to enter the symbol, but you want to enter it as a percentage. So when we actually calculate the probability, we got to change that probability to a percent. All right, so it says a quick quiz consists of a true-false question followed by a true-false question. If both questions are answered with random guesses, find the probability that both are correct. Okay, so I'm going to map this out with 2 outcomes. This first blank is for the first question correctly, and the next blank is for the second question answered correctly. So for the first question, how many answers are there to choose from? 2, right? It's either true or false. Out of those 2 responses, how many is right? Just 1. So you have a 50% chance of getting it right? 1/2. What about the second question? Same deal, right? There's 2 questions, only one of them is right. So we're going to multiply the numerators. So 1 times 1 is 1. We're going to multiply the denominators. 2 times 2 is 4. When you divide 1 by 4, you get 0.25. If you put in 0.25, you're going to get this question incorrect because it wants to answer it as a percent. So in order to convert 0.25 to a percent, we got to do what? Move that decimal twice to the right, attach a percent symbol, and we get 25%. This is like the only question on the test that wants you to answer it as a percent. Everything else is like either a fraction or a decimal rounded. Okay. All right, so you will see these questions on the test now. All right, number 8 says a study of 51% of Americans support increased funding for public schools. If 3 Americans are chosen at random, what is the probability that A, all 3 of them support increased funding, B, none of the 3 support increased funding, and C says at least one of the 3 support increased funding for public schools? All right. So here again, they're talking about all Americans. So this would be a large population of people. So these would be independent events, randomly choosing 3 people, right, all over America. So for A, we're going to map out 3 outcomes, right? So these are the probabilities for the 3 people that we're choosing. So what's the probability that the first person supports increased funding? Well, they give us that probability in the question, right? It says that 51% are going to support it. So the probability that the first randomly chosen person supports increased funding is going to be what? 51%, right? Remember, you got to change that percentage to a decimal in a calculation. And that 51% is going to be the same probability for that second and third person, right? 0.51. So that's 0.51 to the third power. And that probability should be 0.133. So if I'm rounding the 3 decimal places, I look at that third decimal place, which in this case is a 2. You then look one number to the right. Since that number is higher than 5, we're going to round that 2 up to a 3. So we get 0.133. B says none of the 3 people support increased funding for schools. Now, they didn't quite give us this probability, but we can figure it out, right? So first off, I want to just map out 3 outcomes. 1, 2, 3. So again, these are for the 3 randomly chosen people. So if 51% support it, then the complement, and we're going to talk about complement in the next chapter, the complement or the opposite, they're not going to support it, right? So how will we find the probability or the percentage of people that don't support it, right? We're just going to subtract from 100%, right? Because 100% would be all Americans. So if we were to subtract 151, we get 49, right? So that 49%, and again, this is percent, so I'm going to move that decimal. So there's 49% who don't support it. So the probability for the first person is 0.49. Let me just write that up here. 100% minus 51% is equal to 49% that do not support. All right. So the probability of the second person not supporting is the same and the third person. So writing that out in exponential notation is 0.49 to the third power, which is 0.118. All right, so it's about 11.8% of the people do not support it. Right, for probability for choosing 3. Now for C, this is that probability of at least 1. Whenever you see the probability of at least 1, that's equal to the probability of 1 minus none. So the none, we just found that in that previous calculation. All right, we found the probability that none of the 3 people supported. We found that probability to be 0.118. So we're going to use this 0.118 in the probability of at least 1. Right? So this is going to equal to 1 minus 0.118. So 1 minus 0.118 is 0.882. All right. So it's about 88.2% of the people. Well, the probability of at least one of the 3 people would be 88.2%. So the probability of at least 1 is always a probability of 1 minus none. Now, number 9 is something that we hadn't talked about this one. It says a card is drawn randomly from a deck of ordinary playing cards. What is the probability that the card is a club or a jack? So now we had 2 previous problems before with that word or, right? I believe one was here, right? Red or white. So we didn't have any red, white balls in the jar or whatever. So we didn't use that little addition principle. But if I go back down, so first off, I'm gonna just pull up all I really want is just, not everybody's familiar with cards. So just to explain, a standard deck of cards has 52 cards in it, right? You have clubs, diamonds, hearts, and spades, right? And they run in this order. I'll depend on what game you're playing, but you have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have a jack, a queen, and a king. So altogether, you have 13 cards. You have 4 suits, which gives you a standard playing deck of 52 cards, right? Our question says, what's the probability of the card is a club or a jack? Right. So if I go back to the playing cards, how many clubs do we have? Should be 13. How many jacks do we have? 4. But there's a jack that's a club. It's in both of those categories, right? So for this problem, we must use the addition principle, right? We didn't use it in the marbles because we didn't have any red, white, straight marbles, right? Everything was just red or everything was just white. Okay. In this particular case, we have clubs, we have jacks, but one of those is a jack and a club, so we have to take out that probability, right? We got to subtract it out. So for this one, we're going to use the addition rule. Here's up.
Thank you.
So to just show where this was in the lecture notes, I think it was in module 2, part 2. Bless you. It was this first thing, this addition rule. It says to find the probability of event A, and event A would be the probability for a club, and event B would be the probability of a jack. We begin by finding the total number of ways that A can occur. So we're going to find the total number of ways that you can choose a club. Then we're going to find the number of ways you can choose B. So that means we're going to find the number of ways you can choose a jack. But we find the total without counting any outcome more than once. So we have something that's in both of those categories. It's a jack and it's a club, right? So I'm going to kind of write this out in words. It says the probability of A plus or that's equal to the probability of A plus the probability of B minus the probability of A and B. Okay. So just to write this out in words so you can see it a little bit better. It's A would be the probability that the card is a jack. So that's the probability of a jack or the probability of a club or the probability of a jack. Okay. That's going to equal to the probability of a club plus the probability of a jack minus the probability of a jack and a club. And this is the reason that we must use the addition rule. So now let's just find these three probabilities, and then we're going to calculate the probability that the card is a club or a jack. So what is the probability of choosing a club? Right, so there's 52 cards altogether, right? And then there's how many clubs? 13. So the probability of choosing a club is 13 out of 52. Plus, what is the probability of choosing a jack? Right, there's 4 jacks, 52 cards. So plus 4 out of 52 minus, what's the probability of choosing a jack of clubs? 1, right? So that probability is 1 out of 52. So is everybody okay where I'm getting these fractions from? When you add or subtract fractions, you must have a common denominator. So the common denominator is 52. So I don't multiply these denominators together like we were doing when we were multiplying. We're going to keep the common denominator. We're going to combine the numerators. So 13 plus 4 minus 1, that's going to give us 16 over 52. And 16 over 52 is 0.308, rounded to 3 decimal places. 0.308. If you wanted to answer that as a fraction, 4 over 13. Right. Any questions about number 9? You will see one similar to that on the test. Right. Number 10. Okay, that deals with the contingency table or the two-way table. So we have males and females, and then we have grade totals. Right. There's 82 males and females combined, and there's also 82 letter grades, A, B, and C. So on these problems, remember, if you see the word given, you have to restrict your denominator. If you do not see the word given, then you're going to use 82 as your total. Right? So A says find the probability that a student received a C in the class. Right? So how many students are in the class altogether? 82. And how many students received a C? 35. Right? Because I'm looking at my C total, which is 35. That should be 82. The number of students that received a C was 35. Right? So we get 35 out of 82. Find the probability that the student is male. Well, how many students altogether? 82. Out of those 82 students, how many are male? 33. Find the probability that the student was male and received a C in the class. So I don't see the word given. So we're going to use the total amount of students in the class, which was 82. And I'm going to look for the males that received a C, and that should be what? 16. So now 16 over 82, that's not simplified. So 8 over 41. All right, just make sure if you're putting in fractions that they must be simplified. All right, so any questions up to this point? Now for D, we see the word given. It says find the probability that the student received an A in the class given they were female. So given they were female, how many females were there in the class? 49. So notice I'm not using the 82 total. I'm using only the amount of females, so that's 49. Out of those 49 females, how many made an A? 10. So that's 10 over 49. Right? E says find the probability that the student is a female given they received an A in the class. So what is the denominator for this one? Right, so it says given that they received an A, so how many students received A's? 18. So our denominator is 18. Out of those 18 students that received A's, how many were female? 10, right? So that probability is 10 out of 18. And then we have to reduce that down, right? So I think you divide both of those by 2. 5/9. F says find the probability that the student is female and received an A in the class. So now I don't see the word given, so we're going to use the denominator as all of the students in the class, which was what? 82. Out of those 82 students, how many were female and received A's? 10. So that's 10 out of 82. If we reduce that down, it's 5 over what? 41? 5 over 41. All right, and the last one says find the probability that the student received an A and they are male. So I don't see the word given. So our total here is what? The 82 students in the course. Out of those 82, how many were male and received an A? 8. Right. So that's 8 out of 82, which reduces down to 4 over 41. All right, any questions about the contingency table? Just be careful. Whenever you see the word given, don't use that row column total. Okay, you only want to restrict. Oh, I skipped over one. All right, it says find the probability that the student received. That's the same question, right?
No, that one has given in it.
Oh, okay, yeah. Please be careful. I was look exactly the same. Okay, G says find the probability that the student received an A given they are male. So what's the denominator? It's going to be 33, only the male students, right? Out of those 33 male students, how many received an A? 8. So that probability is 8 out of 33. Right.
So we can write it in decimal, right? We don't have to write it in fraction.
Yeah, you could just write it in decimals. Yeah, I'm just doing it kind of to save a little bit of time. Just make sure we get through all of this. All right. And there's 20 questions on the quiz, and there's going to be 20 questions on the test. 20 questions on this review. And I think there's 20 on the quiz and then 20 on the test. All right, 11 says a state license plates contain 3 letters followed by 5 digits. How many possible license plates can be issued using this condition? So notice now, this question is not asking for a probability. It's simply asking for how many possible license plates. So we're going to use that fundamental principle of counting, right? So we're just going to map it out. We have 3 letters, right? So those blanks represent the first 3 letters chosen. And then we have 5 digits. All right, so those last 5 blanks represent the last digits. So if the first character is a letter, how many choices of letters are there to choose from? 26, right? Right. So now in this one, this can include repeats, like you can have like AAA or BBB. All right, so it doesn't stipulate that the letters can't be used twice, right? So how many choices for the second letter? Should be that same 26, and then the same 26 for the third letter, followed by 5 digits. So how many digits are there to choose from? Should be 10. So remember, a digit is just a single whole number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 through 9 gives us 10 numbers. All right, so we have 10 choices for all 5 digits. So I'm going to write this in exponential notation. So this can be written as 26 to the 3rd power times 10 to the 5th. Now, when you put this on your calculator, something funny is going to pop up. So I'm going to evaluate that 26 raised. So I'm using this caret, right? That's the exponential key on this graphing calculator. Times 10 raised to the 5th. This did something early. I got like an E. Did anybody get an E on their calculator? Okay. That's kind of crazy. So this would be 17576. So that would be 1,757,600,000 possible license plates, which is a lot of license plates. I don't think it's a billion people in a state. All right, number 12 and number 13, they get into permutations and combinations. So just remember that in a permutation, the order matters. In a combination, the order does not matter. So whenever you think of permutation, you should think of plays. You should think of runners running a race and placing like 1st, 2nd, and 3rd. Those are like prime examples of permutations. So we look at number 12. It says you have 6 volunteers for a play. So that should automatically alert you that this is probably a permutation because the characters matter. You wouldn't just, if you were doing Romeo and Juliet, you would probably want a male to play Romeo. You wouldn't just pick people at random, right? So this would be a permutation. It's 6 volunteers for a play that has 5 characters in it. How many ways can you cast a play? Well, now we have deduced it down to a permutation. You need a value for N and you need a value for R. N is going to be the total to choose from. So how many people do we have to choose from? 6. So our N value is 6. R is going to be the number of things needed or number of things chosen. So out of these 6, how many are we going to actually choose in the play? 5, right? Because there are 5 characters. So when you write out your permutation, you always put your total first. So there's 6 people. And we're going to permutate 5. And even in a combination, that total amount of things you're choosing from comes first. So we're going to use the calculator. So the first thing we must do is enter in our total, which is 6. I'm going to go into math. I'm going to scroll over to PRB, which is short for probability. We're going to choose that second option, which is permutation. And out of those 6 people, we're going to choose 5 characters for a total of 720 ways we can cast a play. So that is a permutation. Right? So when you see that play thing on the test, that's a permutation. All right, 13 says a basketball team consists of 15 players. If 5 people can be on the court at one time, and it does not matter which position anyone plays. That is a key statement in this problem because if you're not worried about positions, you can get like the shortest man to play center. And in a real real game, you probably wouldn't want that. Right? So it doesn't matter who plays what position, so this is a combination. How many different groups can be selected to be on the court? So we've deduced this down to a combination. We have to choose a value for n. So n is going to be what for this particular problem? Right? It's going to be the total number of people we can choose from, right? Which is 15, right? R is going to be the value of people that we actually need. So for this example, we need 5 people to be on the court at one time. So my R value is 5. So we're going to put this in the calculator as 15 combination 5. So this is 15. I'm going to go over the probability. I'm going to choose that third function, which is combination. Out of those 15 people, we want to choose 5. So we get 3,003 different possible combinations. All right. So any questions so far? All right. Number 14. It says Hamari owns all 5 books in the Percy Jackson series. It was Spiderwick the last time. I don't know what Percy Jackson is, but the Percy Jackson series, and how many different orders can she place all of the books on a top bookshelf? All right, so we're going to map this out using that fundamental principle of counting. Right, since we're choosing 5 books, right, I'm just going to map out 5 outcomes. So I just put some books over here. 1, 2, 3, 4, 5. So for the first book on the bookshelf, how many books are there to choose from? 5, right? So let's just say I choose this one. For the next book on the bookshelf, we now have how many? 4. So let's say I choose this one. For the next book on the bookshelf, we have how many books to choose from? 3. So I choose that one. For the next book on the shelf, how many are left to choose? 2. All right, and then for the last book on the shelf, there should be only one choice, right? So this is that factorial concept, 5 times 4 times 3 times 2 times 1, which should give us 120, right? So there's 120 different ways we can order the books. Right, so notice that these 3 questions didn't really ask anything about probability. They just wanted to know how many ways can you order or choose something. All right, number 15. Okay, this is the one where it says 5 different colored 4-sided dice are rolled. I ain't never seen a 4-sided dice. I'm gonna have to look that up. Okay, I've seen an 8-sided dice before. I actually had one. I don't know what happened to it, but I've never seen a 4-sided dice. I don't even know how that'll roll. All right, and the numbers shown are recorded. How many different outcomes are possible? So notice this is not a probability type question. It's a different outcomes. So we got 5 different 4-sided dice. So I'm going to map out 5 outcomes, and these outcomes are just the dice in my hand, right? So how many choices of colors do we have to choose from on the first dice? 4, right? Now these are going to be independent, right? One dice doesn't have anything to do with the other dice because it doesn't really say if you're rolling them one at a time or if you're rolling them one by one. But I know I got 5 dice. So for the second dice, how many outcomes? Still 4, right? Because each one of these dice has 4 sides. And it's going to be 4 outcomes for all 5 of those, right? So if we write this in exponential notation, we have 4 raised to the 5th power, which is good, 1024. I just gotta look that up. 4-sided dice. What does that look like? This looks like a triangle with a base. All right. I just had to see what that looked like. Okay, number 16. Now we did one like this in class, but we didn't actually find the standard deviation. It says find the mean and the standard deviation of this probability distribution. So keep in mind for a probability distribution, there are generally 2 columns. The first column is the random variable. So the definition of a random variable is just that it's a single number value, right? The second column is the probability, right, for that random variable. I think we've seen a donut example. The conditions for a probability distribution is that you must have a random variable, you must have the probability for that random variable, and all of your probabilities must add up to give you 1. So we've already had I'm just going to check this out, right? If I take 0.05, 0.05 plus 0.25 plus 0.25 plus 0.45, we should get 1, right? It must add, your probabilities must add up to 1. So they're not pulling any tricks in this one, okay, where it's not adding up to 1. So we got to find the mean and the standard deviation. So we're going to take the random variable, we're going to put that in as list 1. We're going to take the probability, we're going to put that in list 2. Now we're going to do something a little bit different. Instead of using, I think I used the mean function. Since this asks for the mean and the standard deviation, I want to use that one variable statistic. All right, so let's put in the random variable is list 1 and the probability is list 2. So in order to access the list, I'm going to hit stat, and I'm going to choose that first option which says edit. I'm going to put in the random variables. One, 5, 10. Nope. 1, 5, 8, and 10. I'm going to put in the probabilities. So once you put in list 1 and list 2, I'm going to go back to the home screen. So that's second in mode, which is the quit key. Now in order to find the mean and the standard deviation, I'm going to go back into stat. I want to scroll over to calculate. Now if you have a TI-84, it looks a little bit different after we hit one variable statistics. In mine, I have to tell it which two lists. I'm going to put in list 1, comma, list 2. If you have a TI-84, I think where it says X list, you put in list 1. And I think, was it frequency list? Frequency list, you put in list 2. And then you're going to go down and calculate. And this older model calculator, that layout is a little bit different. So I actually have to tell it L1, comma, L2. And then when you hit enter, the mean is going to be X bar, which is 7.8. The standard deviation is this sigma sub X. And that's equal to 2.5. How many decimal places? 2.54. So notice now, the capital S sub X, that is for a sample standard deviation. They don't give us a value for the sample standard deviation because we are dealing with a probability distribution. And in that probability distribution, you're dealing with a population of 100%. So like when you add up all these probabilities, you get 100%. So notice this S sub X is left blank for that reason. So here the mean is 7.8 and the standard deviation is 2.54. All right, 18 says select the correct histogram for the probability distribution. Let's see if I can blow this up a little bit. So I don't know why this thing says like A, B, A, B. All right, but anyway, on the probability distribution histogram, your random variable is along the horizontal axis. So notice on all of these histograms, the horizontal axis is 0, 1, 2, 3, 4, which represents your random variables. Your probability is actually the height of each one of these rectangles. So I want to find the probability distribution that has the random variable 0, and the probability is 0.26. It looks like this one. I want to find a random variable 1 that has a probability of like 0.22. I want to find a random variable 3 that has a probability of 0.28. So I believe it's going to be this one. So on the horizontal axis, you should see the random variable. The probability represents the height of that rectangle. All right, so we didn't talk about this in the slides, but any questions about the histogram for the probability distribution? Well, this one is just choose a graph. The calculator won't actually. I guess it could. Let's see. I got it in the stats. Let's see. If I go back to my home screen, if I go into stat plot, I have to turn it on. I could go to this with this 1 and this 2, and I think I have to hit zoom stats. No, that's not it. Let's see. I believe it will plot it. I turned it on. Oh, I didn't turn it on. Okay, I got to turn it on first. And then you can find the histogram icon. I highlighted that. X1 is list 1. Frequency, I believe, would be list 2. And then if I go into Zoom stats, I thought it would. Okay, I thought it would, but apparently. Okay. Well, I'll have to go back and do that one. I don't think it'll graph that one for me. All right, number 18. It says a certain brand of cookies sell many cookies in packs of 5, and it has been determined a distributor and has determined a probability distribution for the number of cookies that they sell in any given day. Use the data to answer the following question. You may round to 2 decimal places if necessary. So here again, we have a probability distribution where we have that first column is the random variable. The second column is the probability, but one of the probabilities is missing. It says, what is the probability of selling 15 mini cookies in a given day? In order to figure out that probability, I'm simply going to add up all of the probabilities and I'm going to subtract from 1, right? Because since all of these probabilities must equal to 1, right, I'm going to write this out as 1 minus 0.26 plus 0.35 plus 0.25 plus 0.08. So I believe once you calculate all of that, you should get 0.06. So that means if I were to add up all of these things, like 0.26 plus 0.35 plus 0.25 plus 0.06, which we just found, plus 0.08, you should get 1. All right, so it's like an algebraic type equation was set up to find an unknown value. That's about as far as algebra that we're going to ever do in this class. So now 2 says find the expected number. So remember that expected number is the mean. Which is X bar. So in order to find that expected number of mini cookies sold in a day, we're going to put X in as list 1. We're going to put the probability in as list 2. We're going to do that one variable statistic, and that should give us the mean. And then 3 says find the variance. Okay, so we're going to talk about the variance, but first let's find the mean. So we're going to put the probability distribution into the calculator. Okay, did that go somewhere? Okay, the calculator is freezing up. Okay, 0, 5, 10, 15, 20. 0.25, 0.06, and 0.08. Point 0.26, 0.06, 0.08. I think I got it. All right, 0, 5, 10, 15, 20, 26, 35. All right, so in order to find that mean, once you put the data into list 1 and list 2, go back to the home screen. I'm going to go into stat, calculate one variable statistic. L1 is the X list. L2 is that frequency list. Okay, and we get the mean, which is X bar, that is 6.75. And it asks for the variance. Notice that the calculator is not going to give me the variance, but it's going to give me the standard deviation. The variance is the standard deviation squared. So in order to find the variance, that's equal to the standard deviation squared. So that means we have to take this standard deviation value, which is 5.804, and we have to square it. So notice the calculator is not going to give me the variance. It's going to give me the standard deviation. But the standard deviation can be found, but the variance can be found by taking the standard deviation and squaring it. So 5.804 is the standard deviation. I'm going to square that, and now that gives me the variance, which is 33.69. Yeah, 2 decimal places. 33.69. So if you look at your answer key for number 18, notice it's going to say it's 33.69 and not that 5.804 value. All right, any questions about that one? All right, number 19 says, suppose that 23% of the students on campus wear glasses. If 2 students were chosen at random, what is the probability that they both wear glasses? So we're going to map out 2 outcomes, right? That's for the 2 people that we're randomly choosing. So the probability that the first student wear glasses is going to be what? 23%. The probability that the second student wears glasses should also be 23%. So that's 0.23 squared, which is 0.529, which is about 52%. So it's a good chance that you're going to choose 2 people that wear glasses. And then the very last one says, for families with 5 children, let X be the number of children with genetic condition B. Can the following table be a probability distribution for the random variable X? For this problem, notice that we have the random variable 1 through 5, and then we have our probabilities. What makes this a probability distribution? We have to add up all of the probabilities, and if it totals to 1, then we have a valid probability distribution. If it's something less than 1, we're going over. The answer is going to be yes. Because if you add up all those numbers together, you should get 1, exactly 1. So that makes that a valid probability distribution. All right, any questions? So now the test is going to be taken home. You can use your notes. You can even use what we just went through. This will be very helpful. These were actually test questions. All right. Any questions in general before we dismiss?
So is the test open now?
It's open now. There's no password or anything. All right, well, no further questions. Class is dismissed, and see you all next Monday.